Good day everyone. So for today's lecture, we will discuss tension of a string in a pulley system. So as you can see, this is the diagram of a problem in a pulley system. So here I have two masses. This mass A is connected on a ring, while this mass C is connected in a string that passes through to a pulley system. So let's identify first. So what are the forces acting on the ring? So we have T1 that is going down, T2 that is going to the left, and T3 that is 30 degrees from positive x-axis. So this is almost the same to our problem that we are solving before, but this T3 passes to a pulley system and the end of that string is connected to mass C. So the idea here, if a string passes to a pulley, and since that string is continuous, so it means whatever the magnitude of the tension here is also the magnitude of the tension in this part of the string. So they are just continuous strings, so it means they have the same magnitude but they have different direction. Okay, so I hope that is clear. So let's try to solve this problem. If the mass of the cylinder C is 40 kg, determine the mass of cylinder A in order to hold the assembly in the position shown. So before we proceed on the free body diagram for the ring, let's identify first what are the forces acting on these two masses. For mass A, there are the weight of A and T1, which is going up. For mass C, there is the weight of C, and that is T3, which is going up. So from our previous example, we know T1 is just equal to weight A. So to prove that, that will be T1 minus weight of A is equal to 0, and T1 is just equal to weight of A. Since weight 8 is unknown, so from weight A, we will determine what is the mass of the weight A. For T3, so from this problem, we can see that T3 is just equal to weight C, and to prove that, that will be T3 minus weight C, because T3 is going up, weight C is going down, and we can say that T3 is just equal to weight of C, and we can solve weight of C since the mass of the weight C is given, so that is mass times acceleration due to gravity, so therefore that is 40 kilograms times 9.8 meter per second squared. Weight C is 392 Newton, that is also equal to T3. Since we know what is the equivalent of T1 and what is the equivalent of T3, let's go now to solve to the free body diagram, which is the ring. Okay, now again, there are three forces acting on this free body diagram. These are T1, T2, and T3, which is 30 degrees from positive x-axis. Since there are only three forces here, and this is an equilibrium problem, I can easily use the second method, which is the Sine Law Method. So I will draw this in using the head to tail method. So I will draw first T2, then from at the end of T2, I will draw T3, that is 30 degrees from positive x-axis of this axis. Then at the end of T3, I will draw T1, which is going down. Since this is an equilibrium problem, the resultant of these three forces should be equal to 0. Now, let's identify now the angles by inspection. So the opposite of T1, I will call this as alpha. And as you can see, alpha is just equal to 30 degrees. At the opposite of T2, I will call this as my beta. And the opposite of T3, I will call this as my gamma. So as you can see, this is a right triangle. So therefore, gamma is 90 degrees. And since gamma is 90 degrees and the total angle in triangle is 180 degrees, so therefore beta is 60 degrees. So our goal is to find the weight of mass A. So that is for T1. So let's try to solve first T1. And based on our given, we know T3. So we will use the formula for Sine Law Method, in which T3 over sine gamma, and we will use this to find T1. So therefore, T1 over sine alpha is equal to T3 over sine gamma, and to find T1, it will just be equal to T3 sine alpha over sine gamma. And let's substitute now the given, so it will be 392 Newton, so that is the value of T3. Then sine 30, so that is the alpha. And sine 90, that is gamma. So the answer for T1 is 192 Newton. This T1 is also equivalent to weight of A, but we are going to determine the mass. So therefore, we will use WA is equal to mg. So that is mass times acceleration due to gravity. And we will derive this one. So it will be mass is equal to weight of A over g. So that is 192 kilogram meter per second squared divided by 9.8 meter per second squared. Remember, kilogram meter per second squared is equivalent to Newton. We can easily cancel out the same units. So what is left is kilogram. And the answer now is 19.59 kilogram. So I hope this is clear for this type of problem. So let's answer another problem, which is this. So the block has a weight of 20 pounds and it is being hoisted at a uniform velocity. Determine the angle for the equilibrium and the force in chord AB. So remember, from the word uniform velocity, if the problem is moving in a uniform velocity, so it means it's constant velocity. So therefore, if the velocity are constant, the acceleration is 0. And if the acceleration is 0, the summation of forces is equal to 0. So this is an equilibrium problem. Okay, so let's try to analyze the figure first. So we have a pulley here, and on the pulley, there is one cord that is connected to it. So that is cord AB. And there is another cord that is passing through to a pulley. So that is a continuous cord, which is cord CAD. Okay, so let's call this cord AB as my T1, since this is the point of interaction of our problem. So this T1 is pulling this pulley going to the second quadrant, while for this cord, I will call this as my T2, and this cord is pulling my pulley going downward. And since this is a continuous cord, so it means this is also T2, but the direction of my T2 is going to the fourth quadrant. So after we identify the forces acting on the pulley, okay, so now let's identify the forces acting on the block. So there is a weight of the block and there is T2, which is going up. So from here, we can easily identify that weight is just equal to T2. So that is the weight, and that is the direction of the weight, and that is T2. So to prove that weight is just equal to T2, so it will be the summation of forces is equal to 0. T2 minus weight is equal to 0. So that will be T2 is just equal to weight. And since the weight here in the problem is 20 pounds, so therefore T2 is just equal to 20 pounds. Based on this, we already determined what is T2, what is the magnitude of T2 on this cord. So let's go back to the figure before. So let's put this in a free body diagram. So this one is the pulley. So what are the forces acting on the pulley? We have T1, which is 20 degrees coming from positive Y. So from here, we have to place this 20 degrees near to the origin. So since this is the origin and this is my axis, so for that is x-axis. And if we will look here, this is 90 degrees. So this is also the y-axis. So if this is 20 degrees, so definitely this is 70. And if that is 70, this is 20 degrees. That's why we place 20 degrees on this part. Okay, so that is for T1. T2, which is directly on negative y, and T2, which is with an angle from negative y, which is theta, and T2 is in quadrant 4. Okay, now in this problem, since there is an unknown angle, we cannot use the second method, which is the Sine Law Method. So since we are going to use the long method, and there are two forces that is in between quadrants, we will get their components. So we have here T2, which is along negative y, and we have T1 here. We will get the component of T1. So that will be T1x, which is along negative x, and T1y, which is along positive y. Now for t2, t2x, which is going to positive x, and t2y, also t2y, which is a negative y. So this is our free body diagram, which are the forces acting on the pulley. So from here, we can identify that there are 2 forces along x and there are 3 forces along y. So we know what is already T2. We are going to identify what is T1 and theta. So again, if there are 2 unknowns in which there is unknown angle and unknown tension, we will identify first what is the unknown angle. Okay, so let's start with the summation of forces along x. So again, we have 2 forces along x here, so that is positive first. So that is T2x minus T1x is equal to 0. So if you will look here, so this is T2x and this T2x is also this one, this part. Okay, so this is also T2x. So if we will look the relationship of theta to T2x, so that is opposite. So that will be sine. So what we have here is T2 sine theta, while for T1x, that is also here. So this one is also T1x, and that is also opposite of 20 degrees. So it will be T1 sine 20 degrees. So this will be the formula for getting the components of T2x and T1x. Now, since we know what is T2, we don't know what is theta, and we don't know what is T1, so there are 2 unknowns. We cannot proceed on this equation, so we have to go to the forces along y. So the forces along y is equal to 0. So again, we identify now 3 forces along y. That will be T1y, which is going up, minus T2y minus T2. So that is the formula. So we will replace all the forces with subscript. So T1y is the adjacent of 20 degrees and T2y is also the adjacent of theta. So that will be cosine. So it will be T1 cosine 20 degrees minus T2 cosine theta minus T2 is equal to 0. So we don't know what is T1. We know what is T2, but we don't know what is theta. So what we're going to do is we will combine this. So again, we are going to solve theta. So I'm going to replace T1. Okay, so to replace T1, I will use this equation. So I will derive this so that I will have an equation which is equal to T1. First thing is I have to transpose this one to the other side, T1 sine theta on the other side. So that will be T2 sine theta is equal to T1 sine 20 degrees. Then divide both sides by sine 20. So that will be T1 is equal to T2 sine theta divided by sine 20. Now, let's substitute the value of T1 on this. So it will be T2 sine theta over sine 20 degrees cos 20 minus T2 cos theta minus T2 is equal to 0. And let's simplify. So to simplify this one, I have to transpose T2 on the other side. So just like this, so that I can have here in one side variables that has an angle and the other side which has no angle. Then I have to multiply both sides by sine 20 degrees. So what will happen here? So I have to multiply both sides by sine 20. So it will be T2 sine theta cos 20, because I can cancel out sine here, sine 20 here. Then T2 cos theta sine 20, T2 sine 20 degrees. Okay, since all of these variables has T2, so I can cancel out T2. So what is left here is sine theta cos 20 minus cos theta sine 20 degrees is equal to sine 20. So if you are familiar with this, so we can use an identity for this. So we have to note this identity, which is addition and subtraction trigonometric identity. So in which sine theta cos 20 degrees minus cos theta sine 20 degrees is just equal to sine theta minus 20 degrees. So it will be just like this. So sine theta minus 20 degrees is equal to sine 20 degrees. So I can cancel out sine here because both of them are with sine. So what is left is theta minus 20 degrees is equal to 20 degrees. So I have to transpose negative 20 on the other side. So theta is now 40 degrees. So since we know what is theta, which is 40 degrees, let's use now our formula previously, in which T1 is just equal to T2 sine theta over sine 20 degrees. So T2 is 20 pound and theta is 40 degrees. So let's substitute. So 20 pound sine 40 degrees divided by sine 20. So T1 now is 37.59 pound. So I hope this is clear in solving problems using a Pulley system.